Hi everyone, I'm Cheryl. In this problem, we're going to be using cylindrical coordinates to help us get the volume generated by a sphere and also a cylinder. We're looking for the volume of the solid inside both of them. Okay, so since we're using cylindrical coordinates, let's make that conversion first of all. Now I know that to convert that x is going to equal r cosine theta, y equals r sine theta, and z is just going to be set at z. So let's take a look first of all at the sphere. So for the sphere, if I write this using cylindrical coordinates, I'm going to have r squared cosine squared theta plus r squared sine squared theta plus z squared equals 36. I can factor an r squared out of these first two terms, and I've got r squared times the quantity cosine squared plus sine squared, which is 1. So I've got r squared plus z squared equals 36. Z squared then can be written as 36 minus r squared. Okay, so that's what a sphere would look like using cylindrical coordinates. So now let's go ahead and look at the cylinder. So for the cylinder, we're going to have r cosine theta minus 3 quantity squared plus y squared, which will be r squared sine squared theta equals 9. Okay. Multiplying this first term out, I'll get an r squared cosine squared theta minus 6r cosine theta plus 9, and then plus r squared sine squared theta equals 9. Okay. So this will reduce then. I've got an r squared cosine squared theta plus r squared sine squared theta. That will reduce just to r squared. So I've got an r squared minus 6r cosine theta equals 0, because I'll subtract 9 from both sides. And I can factor this and write this as r times the quantity r minus 6 cosine theta equals 0. Okay, so I'm going to leave that alone for a minute. Now let's talk about how I find the volume. I know that I can find the volume by taking the triple integral over a solid dv. But that's using the x, y, z coordinates. I want to use cylindrical coordinates, so instead I'm going to use the triple integral, and it's going to be r dz dr d theta for my integrand. So let's take a look at what those limits of integration need to be. The first thing I'm going to need to do is look at where z goes. So I know that z squared is 36 minus r squared, which means z is going to bounce between the square root of 36 minus r squared and negative square root of 36 minus r squared. So my lower bound is minus root 36 minus r squared. My upper bound is positive 36 minus r squared. Next, I want to integrate with respect to r. Okay, so let's take a look at what r is here. I know I want to write r as a function of theta, so it looks like r is going to be going from 0 to 6 times the cosine of theta. So I'll be going from 0 to 6 cosine of theta. Now, if you think about what r equals 6 cosine theta is, it's going to be a circle in the r theta plane. And I only need to go from 0 to pi to get the complete circle. So my limits of integration for theta are going to be from 0 to pi. Okay, I have my triple integral all set up. What I need to do next is evaluate. So I'll start with the inside integral. Okay, so the integral from 0 to pi, the integral from 0 to 6 cosine theta, And my first piece is just going to be the integral of r dz, which is just rz, evaluated from minus the square root of 36 minus r squared to positive root 36 minus r squared, and I still have my dr d theta. Okay, plugging in my upper and lower limits, I get the integral from 0 to pi, the integral from 0 to 6 cosine theta. When I plug in my upper limit, I'll have r times the square root of 36 minus r squared. When I plug in my lower limit, I'll have minus r times minus square root of 36 minus r squared. When I combine those together, I just get 2r times the square root of 36 minus r squared. And that's dr d theta. Okay, so now I'm ready for the next integral. Okay, so I've got the integral from 0 to pi. All right, this is going to require a small u substitution, but if you think about it, we're going to end up with just a minus in the front, and this is the square root of 36 minus r squared is going to be 36 minus r squared. Since this is to the 1/2 power, it'll now be raised to the 3/2 power divided by 3/2, which is the same thing as multiplying by 2/3. And then I'll evaluate that from 0 to 6 cosine theta. And I still have my d theta. Okay, plugging in my upper and lower limits, I have the integral from 0 to pi, and I'll have a minus 2/3 times the quantity 36 minus, this will be 36 cosine squared theta raised to the 3/2 power. Okay? And then I have to subtract what happens when I plug in a 0. And when I plug in a 0, I'll have a minus 2/3, so that'll be a positive 2/3, 36 to the 3/2 power. And then I still have my d theta. All right. So now let's see if I can simplify some things here. I notice that I can factor a 36 out of this, but when I factor it out, it'll be 36 raised to the 3/2 power. So the integral from 0 to pi, I've got a negative 2/3, and I'll have 36 to the 3/2 power, which is 216. And then inside here, I'll have a 1 minus cosine squared, which is the same thing as sine squared. So I'll have sine squared theta, but it's raised to the 3/2 power, so that makes it sine cubed theta. Then I have a 2/3 times 36 to the 3/2 power, which I already said was 216. And then all of this is still times d theta. Okay, well, I see a lot of things that are similar, some constant multiples. So let's go ahead and pull those constant multiples out. So I'm going to take the minus 2/3 times 216. That's actually 144. So I'm going to factor out 144. And then I'll have the integral of this will be a minus sine cubed theta plus 1 d theta, and d theta, or the limits of integration are 0 to pi. All right, now it looks like we're done, but remember, this is a somewhat tricky integral. So we're going to have 144, the integral from 0 to pi. I'm going to pull out a sine theta. Let's pull out a minus sine theta. And sine squared can be written as 1 minus cosine squared theta. And then I still have my plus 1 d theta. Okay, so I've got 144, the integral from 0 to pi. I'll have a minus sine theta plus sine theta cosine squared theta plus 1 d theta. Okay, now I should be able to integrate each of these pieces now. So I have 144 times the quantity. The integral of minus sine theta, that's going to be cosine theta. Here I'm going to do a u substitution, letting u be cosine theta. So I'm going to end up with a minus cosine cubed theta all over 3. And the integral of 1 d theta is just theta. And I need to evaluate all of that from 0 to pi. So I've got 144. I'm going to have the cosine of pi. The cosine of pi is -1. Here again, I've got the cosine of pi, which is -1, and -1 cubed is -1, but I've got minus a -1, so that's going to all be a plus 1/3 and plus pi. Now I have to subtract what happens when I plug a 0 in. So I'm going to subtract 144 times the cosine of 0 is 1. Again, the cosine of 0 is 1. 1 cubed is 1. So I'll have a minus 1/3 here. And I'm adding in 0. So we've got 144 times -1 plus 1/3 is going to be a -2/3 plus pi. And I'm going to factor out that 144 here as well. So I'm going to have a -1 and a plus 1/3. So I've got 144. And I'm going to have a -2/3, and this will be another -2/3, so that's a minus 4/3 plus pi. I hope that was helpful. Thanks.